In this tutorial, I'll walk you through the process of finding the limits of a piecewise function using GeoGebra with some examples. Now let's learn how we can use GeoGebra to find the limit of a piecewise function. Before that, let's define piecewise function. A piecewise function is a function that is defined by different formulas on different parts of its domain. That means that the function can have a different expressions for different intervals, right? That's basically what we call piecewise function. So for piecewise function, we are going to analyze how we can use GeoGebra and find the limit of a piecewise function. So now let's come to the command window. By coming to the command window, we type if, and then you see some pop-up menu over there, and then they have the first one, if condition then, and then condition then else. We use the second one. So the first one indicates the condition, and we are going to use the function h of x, which is 2x plus 2 for x less than 1 and 2x minus 4 for x greater than or equal to 1, right? So in doing that, the first condition is x less than 1, right? X less than 1. Other condition, that means if this condition satisfies it, what should the GeoGebra do? We should plot a function. So that then represents a function. So we need to put there a function. So the function should be 2x plus 2. Else, this means that if the condition of x less than 1 does not satisfy it, right, it should plot another function. So then here you can place the other function, which is what? 2x minus 4, right? And it will work. But just that when you press enter, instead of you seeing the x greater than or equal to 1, it will show otherwise, which is basically the same. Any way that you do it, or any way that you can do and understand the concept, it's acceptable. But for me personally, if I'm doing something like this, I want all the conditions to show, so that if anyone picks your work, because you can see that, okay, this is what it means. Maybe yes, this is what it means. So I think for this I won't use this. Let me use the other one. So you come there again, you press if, and then you click on the second one. We type our first function here, our first condition here, which is what? X less than 1. We move there, our function is 2x plus 2. And then for the else part, just write again, and then select the first one, because there are only 2 functions. If it's 3 functions, you can select the second one so that you continue from there. So this means that the condition, and then it should plot it. So the second condition is x greater than or equal to 1. That is x greater than or equal to 1. And then the function should be 2x minus 4. Right. So let's see how things go here. Yes. So when you are done, you just press enter. Means there's a mistake inside the input that I've done. Right, yes, I can see n. So yes, it has to show. So when you are done, you press enter. Then you can see that now all the conditions are showing. When doing this, we are going to do a neighborhood analysis from both left and right and see the value it will be approaching. Right. So in this limit, we are finding the limit of this as s approaches 1, and if time is there, we can find a limit as h approaches -3. For now, we are focusing on 1. So in doing this, we are creating 2 sliders. As I said, you go to sliders, you click on it, any space. Now the first name is A, we leave it like that. So since we are approaching 1 and we are doing it from the left, we can make our minimum value to be -4, the maximum value can be 0.999. Let me see. Yeah, 0.99, and then our increment as usual we can see 0.1, and then when we are done we click enter. The slider has been created. Now we create a second slider. This will be our second slider. Then we leave the name to be B. Since we are approaching 1 from the right, our minimum is supposed to be 1.001, and then the maximum can be maybe 3, and then the increment can be 0.1. So when we are done with this, we click OK, and our second slider has been created. As we did for the previous one, you connect the slider to the function, right? So in doing that, you come here, and always remember to remove this one from this by clicking here, so that you don't create a different slider again. And therefore, when you want to connect the slider to the function, just come to the command window and then type into bracket the slider value as the x value, so a comma and then f of a. Then you click OK. You can see the points on the graph. We do same for b, that is into bracket b comma f of b. Then you click enter. So as soon as you move the slider, you can see the point moving around, right? So what we need to do is that we want to create an x and y coordinate as we did the earlier video, right? So what we have to do is that we create an x coordinate, which is the slider value, which is a, and then the y coordinate should be 0, and then you click enter, and then you can see that we have it going on the x-axis, right? And then we do same for the y. So here the x coordinate should be 0, and then the y should be f of a, right? And you click enter. You can see it has also been created on the y-axis. Now you can go to lines, go to segments, and then connect them together. And then do same for slider B. You can pause the video and do it and come back and check it out. So slider B, the x coordinates, the y should be 0, so b comma 0, and then we click OK. You can see it has been showing on the y-axis, x-axis, and then we do same for the y, and then it should be 0 comma f of b, right? And then you can see it has been showing on the let me say there's a slider. You can see it's showing over there. So you go to segments, you click on it, and then you use it to connect. Use it to connect this thing. So it then select the segment. Right, so you go there, select it, and then you click on it again. You go here, exactly. So now you can go up and down, up and down. So now let's do some traces on it for you to be able to see things clearly. So with this, show trace on, and then with this, show trace on, and then you can do same for the right, show trace on, and for the left, show trace on. So with this, you can also change the colors by clicking on this one. You go to object properties, and then you go to colors. You can see there you can choose red for the left, and then you do same, but you click on it and then you choose the same red for it, and then you come to the right, you can choose blue for it, and you come here, you can choose another blue for it. So now we are done. So you can click here and close it, and then let's apply the animations to see how things are going, right? Let's apply the animation to see how things are going. So now let's apply the animation. We right click on the slider and then go to animate on. So you can see that After applying the animation, this function approaches, or this point approaches 1 to the top here, you can see that the function value will be approaching 4. And if 1 approaches, this right-sided limit is approaching 1 from the right, you can see this value is approaching -2 down here, of which the right-handed limit and left-handed limits are not the same. Therefore, you can see that this limit does not exist. You can also use tabular approach to check your answers by going to View, then go to Spreadsheet, and then you go to whatever you want to record on the spreadsheet, maybe J. You say record to spreadsheet to do that, right? And then you go to the other side and they say record to spreadsheet, and it should do that for you. So that one I need to click on a different place, then go to spreadsheet, and to do it for you. And one thing that you have to note is that when you keep the sliders, the animation on, it will do it forever, right, for the spreadsheet one. Therefore, you don't have to put the animation on when you are doing this analysis. When you are done, go to record to spreadsheet, then you slide the distance so that you can get the necessary values that you want. I think this video is helpful, and you'll see me once again in my next video. Thank you.